Hi, I'm JD, and what we're going to be doing today is finding the probability of selecting a card in a standardized 52 card deck. So if you would, pause the video and see if you can try these two different scenarios. The first one is selecting an ace or a king, and then the second scenario is selecting an ace or a heart. So if you would, pause the video and see if you can try this one around. Alright, so you're going to be, since it's an OR situation, you're going to be using the additive rule. Well, when you use the additive rule, you have to check to see if it's mutually exclusive or not mutually exclusive. Mutually exclusive, you have, these are two different probabilities in that there is no overlap, right? There's nothing that they have in common. And the second is when they're not mutually exclusive, and you look at the sample spaces of both, and there's actually a little overlap. So when you're using the additive rule, you have to determine this first. So here, with an ace or a king, is it mutually exclusive or is it not mutually exclusive? Right, you can't select an ace-king at the same time. So they are mutually exclusive. So with that in mind, P of A, I'm just going to make, that's the probability of selecting an ace, the probability of selecting a king, make it like that. Alright, so then you add the two probabilities together because it's an OR situation. So the probability of selecting an ace, you want to look at my favorable outcomes and then the total possible outcomes. When you look at a deck, there's 52 cards in a deck, so it's over 52 possibilities, and then this is going to be the same. And then there's 4 suits. You have hearts, diamonds, clubs, spades. If you're not familiar with the deck, usually there's a sample space in your textbook. You just want to be familiar with that. So favorable outcomes for selecting an ace would be 4. And then you have the same thing with a king, right? It could be, again, hearts, diamonds, clubs, spades. So then you add the two together. You get 8 over 52. You can simplify that. 4 goes in each of these, so that's 2 over 13. Now sometimes what they might ask is if you can find it, you know, put the probability as a decimal. So 2 over 13, I get 0.153846154, etc., etc., etc. Now, when you're doing it as a decimal, usually they want to 3 decimal places. They might want it as 2, but usually it's 3. Just check with your teacher or with your textbook. So here, let's just use 3 decimal places. So that would be 0.154. Alright, that's letter A. Letter B, you want to think through, again, is it mutually exclusive? Is there any overlap? Or is it not mutually exclusive? Is there overlap? I'm looking for an ace or a heart. Is it possible to get an ace heart? And the answer is yes. So what you want to do here is subtract out the middleman. So you have the probability of an ace plus the probability of a heart, and then the probability of both an ace and a heart. This symbol right here, just to refresh your memory, like an upside down U, is an AND symbol. So the probability of an ace is over there, so it's 52. It's 4 over 52. Probability of getting a heart, well, you can look at it this way. there's 4 suits in a deck, so it'd be 1/4, or each suit is 13 cards. So hearts has 13, and so it's 13 over 52. Right? If you consider the ace as 1, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 cards right there. And then you have the jack, the queen, and the king. So it's 10 plus 3, which is 13. And you're not adding this, you're going to subtract the overlap. My bad. Minus. And then there's only 1 ace of hearts in a deck. So 1 over 52. So you have 4 plus 13, which is 17, minus 1 is 16. So you have 16 over 52. Both of those are divisible by 4. So 16 divided by 4 is 4. And then 52 divided by 4 is 13. Yeah, so clear. So that's 4 divided by 13, which gives me a probability of 0.3. And again, I'm rounding to 3 decimal places. 0.308. And that's it.